Mastering data visualization with line plots in Matplotlib. In the realm of data visualization, line plots stand as a fundamental tool, providing a clear and concise representation of trends and patterns within datasets. As one of the most versatile plotting techniques, line plots in Matplotlib offer a straightforward approach to interpreting data, making them valuable across various fields and applications. What is a line plot? A line plot, also known as a line graph, is a graphical representation of data points connected by straight line segments. It typically depicts the relationship between two variables, with one variable represented on the x-axis and the other on the y-axis. Each data point is plotted as a marker, and lines are drawn to connect these points, emphasizing the continuity and trend in the data. You can see this image, which is an example of line plots. Because each data points are connected with a straight line. Importance of line plots. Line plots serve as powerful tools for visualizing trends and patterns over time or across different conditions. Their simplicity allows for quick interpretation, making them accessible to a wide audience, from researchers and analysts to educators and policymakers. Here are some key reasons why line plots hold such significance. Clarity and simplicity. Line plots present data in a clear and concise manner, enabling easy interpretation of trends and fluctuations. The straightforward design of line graphs makes them particularly useful for conveying complex information in a digestible format. Identification of trends. By connecting data points with lines, line plots facilitate the identification of trends and patterns within datasets. Whether it's detecting upward or downward trends, periodic fluctuations, or sudden changes, line plots offer valuable insights into the underlying dynamics of the data. Comparison of multiple variables. Line plots allow for the simultaneous comparison of multiple variables or conditions. By plotting multiple lines on the same graph, users can easily compare the trends and relationships between different sets of data, aiding in decision-making and analysis. Forecasting and prediction. Line plots can be utilized for forecasting and predicting future trends based on historical data. By extrapolating the existing trend lines, analysts can make informed projections about future outcomes, helping organizations anticipate changes and plan accordingly. Applications of line plots. The versatility of line plots extends across various fields and disciplines, playing a crucial role in data analysis, research, and decision-making processes. Some common applications include finance. In finance, line plots are frequently used to visualize stock prices, market trends, and economic indicators over time. Analysts rely on line graphs to track the performance of investments, identify patterns, and make informed decisions in the stock market. Meteorology. Meteorologists utilize line plots to display temperature trends, precipitation levels, and other weather-related data over different time periods. By analyzing these trends, meteorological agencies can forecast weather patterns and issue timely warnings to the public. Academia and research. Researchers across various disciplines, including biology, psychology, and economics, employ line plots to visualize experimental results, survey data, and longitudinal studies. Line graphs enable researchers to communicate their findings effectively and draw meaningful conclusions from their data. Quality control and process monitoring. In manufacturing and quality control processes, line plots are used to monitor production metrics, track defects, and ensure product consistency over time. By monitoring key performance indicators, KPIs, through line graphs, organizations can identify deviations from desired standards and implement corrective measures. In conclusion, line plots in Matplotlib represent a cornerstone of data visualization, offering a simple yet powerful tool for analyzing trends, making predictions, and communicating insights across diverse fields and applications. With their ability to convey complex information in a visually appealing manner, line plots continue to play a vital role in decision-making and problem-solving endeavors worldwide. Mastering line plot creation in Matplotlib, a comprehensive guide to the plot function. In the realm of data visualization, Matplotlib stands out as a powerful library for creating high-quality plots and graphs in Python. Among its arsenal of plotting functions, the plot function reigns supreme, offering a versatile tool for generating line plots with ease. In this guide, we'll delve into the intricacies of the plot function, exploring its parameters and demonstrating how to create compelling line plots using Matplotlib. Understanding the plot function. The plot function in Matplotlib is used to create line plots by plotting data points on a Cartesian coordinate system. It accepts two main parameters, x and y, representing the data points to be plotted along the x-axis and y-axis, respectively. Additionally, the plot function supports a wide range of optional parameters to customize the appearance and behavior of the plot. Here is the syntax of plot function. Parameters of the plot function. X, the x-coordinates of the data points to be plotted. This parameter can be specified as a list, array, or any iterable object containing numeric values. Each element in the X array corresponds to the position of a data point along the x-axis. Y, the y-coordinates of the data points to be plotted. Similar to the X parameter, the Y parameter accepts a list, array, or iterable object containing the corresponding Y values for each data point. The length of the Y array must match the length of the X array. Color specifies the color of the line plot. This parameter can be specified using color names, hexadecimal color codes, or RGB tuples. If not provided, Matplotlib automatically assigns a default color to the plot. Line style sets the style of the line connecting the data points. Options include solid lines, dashed lines, dotted lines, happy crying face, and more. By default, Matplotlib uses a solid line style. Line width specifies the width of the line plot in points. This parameter controls the thickness of the line connecting the data points. The default value is 1.0. Marker determines the marker style used to highlight individual data points on the plot. Options include circles, O, squares, S, triangles, caret, and more. If not specified, Matplotlib uses no marker by default. Example, creating a simple line plot. Let's illustrate the usage of the plot function with a basic example. Suppose we have the following dataset representing the monthly sales figures for a retail store. Import matplotlib.pyplot is plt. Monthly sales data. Months equals Jan, Feb, Mar, April, May. Sales equals 10000, 12,000, 11,000, 13,000, 12,500. Create a line plot. plt.plot months, sales, color equals blue, marker equals O, line style equals line width equals to. Customize plot attributes. plt.title monthly sales performance. plt.x label month. plt.y label sales dollar. plt.grid true. Display the plot. plt.show. In this example, we use the plot function to generate a line plot of monthly sales data. We specify the months array as the x coordinates and the sales array as the y coordinates. Additionally, we customize the appearance of the plot by setting the line color, marker style, and line width. Finally, we add axis labels, a title, and grid lines to enhance the readability of the plot. By understanding the parameters of the plot function and its versatile capabilities, you can leverage Matplotlib to create visually appealing and informative line plots for a wide range of applications. With its flexibility and ease of use, the plot function remains a cornerstone of data visualization in Python. Until now we have seen what is line plot. Importance of line plots. Applications of live plots. Implementing line plot using plot function. And we saw the parameters for this plot function and we did a small example on this. We learned that using these parameters we can make line plots more beautiful. So in this section of video we are going to learn how to customize the line plots. Also we are going to learn for what components of line chart customization can apply. So line plot is a chart with data points that are connected by the lines. Here representation of data points can happen through markers. Each marker have its own properties. Like color, size, marker edge color, marker face color. We can customize all these properties of a markers. Also there are different types of markers are present to represent data points. Each marker have its own properties and we can customize them. Similarly in line plots, each marker is connected with a single and long line. We can apply customizations on these lines also because lines also have their own properties like line styles, line colors, line width. Even we can customize the color and style for labels and titles. We can add texts and annotations to our line plots to make line plots more informative. In this section we are going to do 4 examples. Each example demonstrates customizations on markers, lines, labels and texts, and finally we are going to do an overall example. So first let's start with customizing the markers. Markers are essential elements for indicating data points on a line plot. Matplotlib provides various marker types, including circles, squares, triangles, and more. Let's explore how to customize markers. Marker types. Set the marker type using the marker parameter in the PLT. Plot function. Marker size ms. Adjust the size of markers using the marker size or ms parameter. Marker edge color (MAC). Define the color of marker edges using the marker edge color or MAC parameter. Marker face color MFC, specify the color of marker faces using the marker face color or MFC parameter. To illustrate the customization of markers in Matplotlib, let's consider a simple example where we have a line plot representing the trend of a hypothetical variable over time. We'll customize the markers to enhance their visibility and aesthetics. Import matplotlib.pyplot is plt. Sample data. X equals 1, 2, 3, 4, 5. Y equals 10, 15, 13, 18, 20. Customize markers. plt.plot x, y, marker equals s, marker size equals 8, marker edge color equals blue, marker face color equals yellow, label equals customized markers. Add legend. plt.legend. Add labels and title. plt.x label x-axis. plt.y label y-axis. plt.title customized markers in Matplotlib. Show plot. plt.grid true. plt.show. In this example, we have a set of data plotted on the graph. The example demonstrates customization. Marker type is changed to squares using marker equals s. Marker size is increased to 8 using marker size equals 8. Marker edge color is set to blue using marker edge color equals blue. Marker face color is set to yellow using marker face color equals yellow. Legend, labels, and title are added for clarity. Finally, the plot is displayed with a grid. Customizing lines. The lines connecting data points play a crucial role in conveying trends. Matplotlib offers versatile options for customizing line styles, colors, and widths. Line style, choose from a range of line styles such as solid, dashed, or dotted using the line style parameter. Line color, set the color of lines using the color parameter with options like R for red, G for green, etc. Line width, adjust the width of lines using the line width parameter. Let's dive into customizing the lines in Matplotlib. We'll use the same example dataset and customize the lines to differentiate them visually. Import Matplotlib. Pyplot is plt. Sample data. X equals 1, 2, 3, 4, 5. Y1 equals 10, 15, 13, 18, 20. Y2 equals 8, 12, 10, 16, 18. Plot with default lines. plt.plot x, y1, label equals default lines. Customize lines. plt.plot x, y2, line style equals, color equals, green, line width equals 2, label equals, customized lines. Add legend. plt.legend. Add labels and title. plt.x label, x-axis. plt.y label, y-axis. plt.title, customized lines in Matplotlib. Show plot. plt.grid true. plt.show. Explanation. We have two sets of data plotted on the same graph. The first set uses default lines, solid. The second set demonstrates customization. Line style is changed to dashed using line style equals. Line color is set to green using color equals green. Line width is increased to 2 using line width equals 2. Legend, labels, and title are added as before. The plot is displayed with a grid for better visualization. Customizing labels, titles, texts, and annotations. Clear labeling and annotation enhance the interpretability of line plots. Matplotlib provides tools to customize labels, titles, and add informative text and annotations. Axis labels and titles. Label the x-axis and y-axis using plt. X label and plt. Elabel, respectively. Set the plot title with plt. Title. Label and title styles. Customize label and title styles by specifying parameters such as color, font size, and font weight. Text and annotations. Add text to specific coordinates using plt. Text and annotate data points with plt. Annotate. Customize text properties like color, font size, and alignment. Let's explore how to customize labels, titles, texts, and annotations in Matplotlib using the same example. Import matplotlib.pyplot is plt. Sample data. X equals 1, 2, 3, 4, 5. Y equals 10, 15, 13, 18, 20. Plot. plt.plot x, y, marker equals, o, line style equals, color equals, blue, label equals, data. Customize labels and title. plt.x label, time. plt.y label, value. plt.title, customized plot. Customize label and title styles. plt.x label, time, font size equals 12, color equals, green, font weight equals, bold, labelpad equals 10. plt.evlabel, value, font size equals 12, color equals, blue, font weight equals, bold, labelpad equals 10. plt.title, customized plot, font size equals 14, color equals, red, font weight equals, bold, pad equals 20. Add text, plt.text 3, 17, max value, font size equals 10, color equals, purple. Add annotation. plt.annotate peak, xy equals 4, 18, xctext equals 4.5, 17, arrow props equals dict, face color equals, black, arrow style equals 2. Add legend, plt.legend, show plot, plt.grid true, plt.show. Explanation, we've plotted the data with customized markers, lines, and added labels and titles. Labels, x-axis and y-axis, and the plot title are customized with parameters like font size, color, and font weight. Additional text is added at coordinates 3, 17 to indicate the maximum value. An annotation is added at coordinates 4, 18 with the text, peak, and an arrow pointing to the annotated point. The legend is included for clarity, and the plot is displayed with a grid. Let's create a comprehensive example where we customize markers, lines, labels, titles, texts, and annotations in Matplotlib. Import Matplotlib. PyPlot is PLT. Sample data. X equals 1, 2, 3, 4, 5. Y1 equals 10, 15, 13, 18, 20. Y2 equals 8, 12, 10, 16, 18. Plot data with customization. plt.plot x, y1, marker equals O, line style equals, color equals, blue, marker size equals 8, label equals, data 1. plt.plot x, y2, marker equals, S, line style equals, color equals, green, marker size equals 10, label equals, data 2. Customize labels and title. plt.x label, time, font size equals 12, color equals, black, font weight equals, bold, labelpad equals 10. plt.y label, value, font size equals 12, color equals, black, font weight equals, bold, labelpad equals 10. plt.title, customized plot, font size equals 14, color equals, blue, font weight equals, bold, pad equals 20. Add text and annotation. plt.text 3, 17, max value, font size equals 10, color equals, purple. plt.annotate peak, xy equals 4, 18, xctext equals 4. 5, 17, arrow props equals dict, face color equals, black, arrow style equals, 2. Customize legend. plt.legend, font size equals 10, lock equals, upper left. Customize grid. plt.grid true, line style equals, line width equals 0. 5, color equals, gray, alpha equals 0. 5, show plot. plt.show. Explanation, we have two sets of data plotted on the same graph with different markers, lines, and colors. Labels, x-axis and y-axis, and the plot title are customized with parameters like font size, color, and font weight. Additional text is added at coordinates 3, 17 to indicate the maximum value. An annotation is added at coordinates 4, 18 with the text, peak, and an arrow pointing to the annotated point. The legend is included with a custom font size and positioned in the upper left corner. The grid is customized with dashed lines, thinner width, gray color, and slight transparency for better aesthetics. This comprehensive example demonstrates how to fully customize a line plot in Matplotlib, including markers, lines, labels, titles, texts, annotations, legend, and grid. Customizing these elements allows for clear and visually appealing data visualization.